All right, so we left off in part A of this section. We have found a cost function, and now it's our job to optimize the cost function, right? What is the minimum costs? So as I said, in optimization, as you recall, we set derivatives. We take derivatives, set them equal to zero. We find our extrema. Now it's slightly different here because we have two derivatives, right? We have a partial with respect to x, a partial with respect to y. So just I'm gonna start with the partial with respect to x, and just to make sure you understand what's going to happen here. If you treat y as a constant, this is the derivative of this is going to zero out. So what you would have is since both of these terms have x variables in them, you would have to take the derivatives here. Now this is just a chain rule. You would just let u equal x squared plus 4. So f of u would then be 3,000 square roots of u. Find u prime, f prime of u. Same thing over here. You're letting u equal that y minus x squared plus 1. F of u would be 2,000 square roots of u. Just remember that when you take u prime, my apologies, when you take u prime, you are still treating y as a constant, right? So you would have to just make sure that you, when you take u prime, you're still treating y as a constant. But let me go ahead and form the partial. So the partial with respect to x would be 3,000 times x over the square root of x squared plus 4 plus 2,000 times, and I'm going to go ahead and write it, times negative y minus x over the square root of y minus x squared plus 1. Now, I understand that you might have to pause the video. If you're like me, you might have to pause the video and make sure that you can get from here to here. I get that. So feel free to do so. But this little part here, why I factored out a negative, you will understand in just a little bit, okay? So I'm going to go ahead and jump right to the partial with respect to y. And again, so if you're going to treat x as if it were a constant, well, that's going to zero out. And of course, these are easy partial derivatives to these are take. You would just do the same technique. Let u equal exactly what we did on the previous derivative. Just remember that when you find u prime, you are still treating x as a constant. Let me write the partial with respect to y. So we end up with 2,000 times y minus x over the square root of y minus x squared plus 1 and that's going to be minus 1,000. Okay. So, as I said, normally we set derivatives equal to 0. That's how we locate extrema. We are going to do the same thing. We're going to set our partials equal to 0. But we're going to end up with a linear system, right? Or a system of equations. So this is both of my partials. And notice that I have my partials set equal to 0. But I have formed a linear system, a system of equations. I would venture to say that, oh, I don't know, 90% of all applied mathematics will eventually end up coming down to a system of a linear system. It doesn't have to be well, never mind. So yeah, some type of a system of linear equations. So let me go ahead and show you how we're going to solve this system. The trick to this, it's quite savvy actually, but the trick to this solving this linear system is here. So what I'm going to do is I'm going to start here. I'm going to take this minus 1,000, bring it to the other side, and I'm going to end up dividing by 2,000. Okay. So can I do that in one swoop? If you write this, if I bring this 1,000 to this side, that's positive 1,000. And if I have a positive 1,000 divided by a positive 2,000, that equals a half. So working with just my partial with respect to y. So that would mean that I have y minus x over the square root of y minus x squared plus 1 is equal to, well, 1,000 divided by 2,000 is 1/2. And now what's interesting, and now you're going to see what I did here. Do you see how this almost perfectly resembles what we have here, right? Y minus x over the square root of y minus x squared plus 1, except for this negative symbol. So if this negative symbol wasn't here, I could literally plug in 1/2. But because the negative is there, does that make sense that it's going to be negative 1/2, right? Just like any system, we take one equation, solve, then substitute. So it's quite savvy. It's quite savvy. I'm going to be substituting here. I just need to account for this negative. So where does that leave me? That leaves me with, let's take that top equation. So 3,000. Let me see if I can be lazy here. Let's see if I can grab this whole equation. All right. Let's see if I can erase everything in here and then park my negative 1/2. Beautiful. All right, so now we're on to something. So now we have one equation in one variable. You can solve this. You can solve an equation of one variable, right? And in a second, I'll be able to make a statement that x equals. Well, to do that, let's go ahead and, well, half of 2,000 is 1,000, but that's negative 1,000. And I'm going to bring that negative 1,000 to the right side, and I'm still going to divide by 3,000. Okay, so what do I end up with? I end up with x over the square root of x squared plus 4 is equal to, well, if you have positive 1,000 divided by a positive 3,000, you have equal to a third. All right, not good enough. We need to make a statement of what x is equal to. So what we're going to do, this is a proportion, we're going to cross multiply, right? So basically what I'm going to do is 1 times the square root of x squared plus 4 and set that equal to x times 3x, right? So I'm going to cross multiply. All right, so that ends up giving me 3x is equal to the square root of x squared plus 4. All right, let's go ahead. I need to get rid of that square root, right, if I want to solve for x. So I'm going to square both sides. So that gives me 9x squared is equal to x squared plus 4. All right, let's subtract x squared, subtract x squared. So if I have 9x squareds and I take away 1, I have 8 of them. 8x squareds equal to 4. That means x squared is equal to a half divided by 8. That means x is equal to, well, it's plus or minus the square root of 1/2, right? Forget about the negative. I don't know, a negative length doesn't make any sense in our application. So that's just x is equal to the square root of a half, which is just the square root of 1 over the square root of 2, which is just 1 over the square root of 2, or if you rationalize, that's this, what is that? That's the square root of 2 over 2. Either one of these is fine. You have found, what have you just found? Because you're daydreaming, right? I see you. I can't, actually I don't see you, but you found the length right here. You want to, that's the distance that you want to travel. All right, and well, you know what happens at this point. You have to go back and so now that you know the value of x, you're going to have to use this to figure out the value of y. So we end up going back to the well, I'll tell you what, I know this is a long problem. So when I get back, I'll take another break just because I've been told my videos go too long. When I get back, I'm going to plug the square root of 2 over 2 in for x, and I'm going to solve for y.